let's start with some basics. So I just want to start with, in the chat, tell me the different types of triangles that you have heard about. What are the different types of triangles that you know exist? So, yeah, let's go to Simtanda. Scalene, I like that. So if I was drawing a scalene triangle, I would have all three sides a different length. So that would be maybe something like, that would look like a scalene triangle. So we'll call that scalene. What are the other types that we get? Sorry, my graphics thing stopped working. So we're just using my mouse. What else have we got here? So scalene, I think we also get something called an isosceles, retabile, yes. So an isosceles would probably look something like this, where we have, looks like two whiskers and two sides are equal. Scalene, we almost have that all three sides are different. And what is the last one? It's going to be equilateral, where all three sides are equal. So we have something like that. So we had isosceles, and then we have equilateral. So this is what we call classifying triangles by their sides. But if we want to classify triangles by their angles, how would we name triangles? So if I want to talk about triangles in terms of their angles, what are we going to talk about? So we talk about a right angle triangle. Yep, I like that. I see that in the chat. Thank you, Annalena. So a right angle triangle has a right angle in it. Sometimes we call it a right triangle. What other types of triangles do we have that obtuse? An obtuse angle triangle, that looks like a triangle that's kind of bending over backwards. Hey, like it's like someone's falling over. So this would be our obtuse angle triangle. Yep, I like that. What's the last? Well, yeah. What about a triangle that looks like that? It would be an acute angle triangle. And what makes an acute angle triangle acute is that all the angles are less than 90, whereas an obtuse angled triangle has an angle that's greater than 90. That's why it looks like it's falling over backwards. Okay, so you know your basic triangle names. Now, something else that's important is in triangles, when we name them, we give the vertices the capital letters, and we give the sides opposite the corners or the vertices the smaller letter names. So we would call this length over here C, or we could call it AB, but it's quicker to call it little c. And here we call that little a. And over here, if this was corner DEF, often with triangles we use alphabetical order, then that would be called side D, that would be called side F, and that would be called side E, and we use the little letters for the sides. Give me a thumbs up if that makes sense to you and you've seen that before. Give me a thumbs down if, or give me a question if I've lost you. Okay. Awesome, Mensa, awesome. Okay, so let's get going with some basic questions where we have to solve for angles and solve for sides. Let's go to this question over here. I want you to find me the size of angle X, and that's in question C. Let's just see if you can do that. I know it's pretty straightforward, but let's just check. Can you write out what is X and what is the reason we use? what is the size of angle X, and what is the reason we use. So thank you, Atlikhang. So X must just be, the whole triangle adds up to 180. So I'm going to take away 80, and I'm also going to take away 55. And whatever is left is going to be my answer, which is 45. But I can't just make that statement without a reason. And so the reason is going to be sum of angles in a triangle. Sum of angles in a triangle. Awesome, awesome, awesome. Okay, now, a little bit of an upgrade. In this triangle over here, I want you to work out what is the size of the blue angle, what is the size of the red angle. A little bit of an upgrade, but I have faith in you, and if you get stuck, I'm here to help. So you even can ask an audible question because we're live. That's how flexible we are. Let's see if you can find me the red and find me the blue angle. Maybe even form a little equation to help you. I think all of those need to add up to 180, and that's going to be the same reason as up here. So sum of angles in a triangle. But now you have to collect some stuff, and what you're going to see is that 5x plus 100 must be equal to 180. Now, what does that mean the size of x is? Well, you know then that 5x must be equal to 80. And so I agree with Atlikhang that if I divide both sides by 5, I should get that x is 16. But they don't ask, the question doesn't ask for x, it asks for, well, I'm asking you, what is the size of the red angle and what is the size of the blue angle? So let's call it the green angle then, actually. And because otherwise it's confusing. So the green one would just be 3 times 16, which is 48. And the red one would be 2 times 16, which is 32, plus 10, that should be 42. Okay, so when we talk about solving triangles, we can either solve for the angle, we can solve for the side, or we can solve for the area. And in this case, you have solved for the angles using just the property of a triangle, that the sum of angles in a triangle add up to 180. Give me a score out of 10 for how well you understood that first bit. 10 is perfect, 0 is nothing, 5 is some understanding. Give me a score, how you're feeling, just so I can get a sense of where we are as a group. Pop your number in the chat. Be honest. This is the main way I know how you're feeling, is the number scores that you give me. Okay. All right. Well, let's keep going. Let's take the same idea as we were dealing with here, and I'll give you a hint. This is called, the theorem is called the exterior angle of the triangle. And we learn in grade 9 and 10 geometry that the yellow angle here, 3x, is equal to the green one plus the blue one. It's called the exterior angle of the triangle theorem. I want you to use your knowledge to find me the size of x and then to find me the size of the yellow angle, and then find me the size of the blue one. So that's the theorem. I'm just reminding you about it. But if you need me to explain from scratch, basically any triangle, you can extend a side. If you extend that side, you get an exterior angle, and that exterior angle will be equal to the interior opposites. So in this case, the green would be equal to the blue plus the red. And it can happen in different places. Okay, over to you guys and girls. Help me find what x is here. Okay. Let's see. So we've got 3x is equal to 65 plus x plus 15. Now the reason is going to be exterior ext angle of triangle. But we still need to do some work. So we're going to say, take away the x, bring it across. We're going to get 2x is equal to 80, which means x must be 40. Because we're dividing both sides by 2. If x is 40, what is my yellow going to be? And what is my blue going to be? So yellow should be 3 times 40, which is going to be 120. And blue is going to be 40 plus 15, which is 55. Ritabile, lovely. Atlahan, Onalena, you guys are winning at life. Okay, so these are some of the basic facts or theorems that are going to come up in the section a lot. There's going to be new stuff that we add to it, but you need to make sure that you always know how to give this reason and use this fact. Let me find you. Let's jump a little bit and let's do this one. So I want you to find me, and you're going to need to use some new facts here. I want you to find me x, y, and z. And be aware that these two little whiskers, they mean that these two sides are equal. And I want you to also think about what reasons are you using when you find x, y, and z, because there will be answers, but there will also be reasons. So x equals something, but then there will be a reason. Y equals something, reason. And I'm just as interested in each of those facts. I think most of you can remember that angles on a straight line will add up to 180. And so that is where you're going to start with. Help you find what x is. $62. And it is indeed angles on straight line. But because these two are equal, the angles opposite them will be equal. And that is 62. And the reason for that is called angles opposite equal sides. So we go angles opposite. We can abbreviate the opposite with OPP and a dot. So angles opposite equal sides. When we know that the angles are equal, the sides opposite them must also be equal. And so this is going to be 62. Last one is, if that's 62 and that's 62, what does Z need to be? What does Z need to be? So because the angles add up to 180, this has to be 180 minus 62 minus 62, 124. So this would be 56. And the reason would just be sum of angles in a triangle, which I used earlier in the lesson. But you would need to write sum of angles in a triangle. Okay, so those are a couple of extra theorems you need to know about: angles on a straight line, angles opposite equal sides, and so on. All right. Just something I want to point out. I'm not going to go into too much detail, but just want to point it out. What are these two arrows meaning? What are these two arrows about in this drawing, where there are triangles, but there's a couple of things going on? What are they telling us about? Yeah, they're telling us that we have parallel lines. And if we have parallel lines, what you need to be aware of is that corresponding angles are equal. So that would be the two green ones. You also need to know that alternate angles are equal, which could be those two, or could even be those two over there. Those are alternate, they're equal. And then you also need to know that if I took this black dot over here and its relationship with the angle between the parallel lines, what is the relationship between the black dot angle and the red dot angle? What's that called? What is the name of the relationship that we talk about? Those are co-interior, yes. Now, what's important to remember is that co-interior are not equal. Co-interior are going to add to 180, or we say they're supplementary. Now, in the section, if you see parallel lines, you are allowed to use, often students talk about fun, and fun being basically the way of remembering these relationships, where the F is the corresponding angles, the U on its side is going to be the alternate angles. Sorry, the U is the co-interior. I made stuff up there. Sorry. Let me show you that again. The U is going to be the co-interior angles, where you can remember that they are not equal to each other, but they are they add up to 180. And then the N is the alternate angles, where they are equal to each other. So often students remember this like that, and you just need to remember that they still apply in these shapes. Okay, I'm not going to go into that in detail because I think most of you still remember that, but just be aware that it's still, involved. A firm favorite. Okay, if you have a right angle triangle, there is a famous theorem called Pythagoras' theorem, which deals with the relationship between the hypotenuse, so that's the side opposite the right angle, and then the other two sides. Which of these four options do you think describes Pythagoras' theorem accurately? I want you to tell me with A, B, C, or D. So Ritabile is locked in the answer. On Elena, locked in answer. I like it. The most important thing is seeing the side opposite the right angle and knowing that that's squared is equal to the other two sides squared. So that would be b squared plus c squared. Sorry, b squared plus a squared. I had a moment. B squared plus a squared. So is there an option that looks like that? Well, a squared plus b squared is the same as b squared plus a squared. And so the correct answer is going to be B over there. So what I look for is what is the right angle? That's the one that should be by itself when we start. Although things can move around, you could also write that this would be the same. C squared minus a squared is equal to b squared. That's correct, huh? It's just that it's been moved around a little bit. Okay, let's keep practicing this. So show me that you know how to use the theorem of Pythagoras by finding me the size of angle x. Find me the size of angle x using your theorem of Pythagoras. We're just going through the greatest hits of geometry today. Solving triangles. In order to solve a triangle, you need to know these facts. Toby writes, x squared is equal to 5 squared plus 12 squared. But again, we do need to give a reason, and that reason is Pythag. And now what we need to do is realize that this is equal to 169. And then if we square root both sides, we should get that x is 13. Now, this is the easier option because it's finding the hypotenuse. If you had to find one of these, it would be a little bit harder. But yeah, I think you guys can probably do that. So let's move on. Find me the length of this side over here, which is not the hypotenuse, but it is a right angle triangle. So see if you can do, can you find what x is? To write out the statement, write the reason, and then it might be a little bit messy because it may not be a perfect square. It may be what we call a surd. So for me, that would be my first statement, but now I still need to find what x is. So that's 49, but I have to bring the 1 across. So I'm going to end up, and please do ask a question if I'm going too fast, if I've missed out steps. Here, I took away 1 from both sides, or 1 squared, and I got that. And so x will end up being, if I square root both sides, I get the square root of 48. Now, in your calculator, it can also write that as a decimal. So what would I get? So square root 48, 4 root 3, or 6.93. I like to just leave it, if it says round off to 2 decimal places, then the answer would be 6.93. But if you are using this in a next part of the calculation, I tend to just leave it in this form because this form is the easiest way to use it. Like if you want to type it in and use it in another part of the question, like later in the section, you'll see we have triangles that are linked with other triangles. And if you want to reuse that, it's much easier if you just leave it in that form. Give me a thumbs up if you understand what I mean by leaving it in this form so that when you use it later in the calculation, it's quick and easy to retype. Does that make sense? Because a lot of people, they'll type decimals, then it gets super long, but just leave it like that, and then it's easy to type in your calculator. Okay, so what have we done? So we've done Pythagoras. We've done, I think you guys know how to use Pythagoras. I think we need to spice it up. So here is a question which deals with Pythagoras a little bit, but also the area. How do you find the area of a triangle? What can you remember from grade 9 and 10 about finding the area of a triangle? So a half base times height. Siamtanda and Retabile have been most helpful. Now, the problem I can see is in this question, we have, let's say, the base or the height. We have one part that's next to the right angle, but we don't have the other part. I think you need to figure out what this missing part is. Let's call it X. And once you found what X is, you can maybe find the area. But first, let's find the X. Adlikhan, I think let's ask the rest of the group. Is my screen coming through clearly to you, or are you having issues with? We just want to work out if it's Adlikhan's screen or if it's mine. Let me know if it's okay. I think people are, for the most part, it might just be your signal. But the good news is, Adlikhan, is that the recording is available pretty shortly afterwards. And so if you miss a piece, don't be afraid to just scan through the recording. All right, what are we getting for X? So using Pythagoras, we would say 25 squared equals 7 squared plus x squared. Now, you should write the reason. I'm just going to leave there space, and then you know what to write. Then I'm going to get 25 squared minus 7 squared equals x squared. But you know what? I'm just going to square root both sides, and then I would get that. And Shimtanda and Onalena have confirmed that's 24. Okay, if this is 24, which of the 4 options here is going to be the correct answer? Which of the following is the area of this particular triangle? So we have the base, so we go a half, and I'm going to say times 24, because I'm going to make, and then we're going to go times 7. Half of 24 is 12, so we've got 12 times 7, and 12 times 7 should be 84. And because it's an area, it's centimeters squared. So the correct answer is A. Fantastic. Okay, everyone. What I want to do before, we need a little break, a little power break. And so before I go on to the next bit of reminders, so all I'm going to ask you to do, we're not going to do as elaborate a brain breaks as we did last time. All we're going to do is we're just going to stand on our feet. So I want everyone to step away from your table. We've done a solid half an hour, and I've been going quite quickly. And all I want us to do is do 10 to 15 jumping jacks. That is it. Nothing else except 10 to 15 jumping jacks. So we're away from our table. We're making sure we don't whack anything. And we're going to go in 3, 2, 1. Let's go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And that is that. If your heart is pumping, give me a heart in the chat there. If you can feel your heart rate has risen after that jumping up and down experience. I can feel my heart. Let's have a look here. Ooh, I can really feel my heart. Okay, everyone, give me a happy face if you are ready for the second part of the lesson. I want to see some emoticons. I want to see that they do work. You can do it. Don't be scared. Press the button. Maybe the internet's just stopped working for a second. What is going on? Right, there we go. All right. So we are moving on. Oh, I see lots of hands now. Thank you, everyone. I love this. I love these animations as they come flying across the screen. So I want to move on to a little bit of revision of something called SOHCAHTOA and grade 10 trigonometry. And what grade 10 trigonometry allowed us to do was to find unknown angles and unknown sides in right-angled triangles. And so to show you how we did this, we would look at a right-angled triangle and we would see there is something missing that we're trying to find. So in this case, it's the length A. We would then say, look, in this right-angled triangle, there's an angle that we're given, which is not the right angle. This is called the reference angle. And opposite that, we would call that O. Opposite the right angle, we would call that the side H. And the remaining side, we would call that A, or the big A. Then what we would do is we'd look, we'd say, what side do we want? We want to find A. What side do we know? Well, we know H. And then we ask ourselves, what trig ratio involves an A and an H? Can you tell me what trig ratio involves an A and an H? It's cos. Yeah, perfect. Because there's the A and there's the H. Now we have to write this down. So we write the cos, and this is where we use what's called the reference angle. And we go the cos of 31. And that's going to be equal to A, which is this, just this little a over here, over H, which is the thing that we know. Now we have formed a trig equation where the ratio of sides is equal to this. We are trying to find A. And what we need to do to get that A by itself is move the 16 to the other side. And so we go 16 times cos of 31 is equal to A. Which of these four options here is going to be the correct answer? So in our calculators, we just type 16 times the cos of 31, and we are going to get 13.71, which when we round off is going to be 13.7. So this is what we did in this case was we found a missing side using trigonometry. Now, I want to give you a chance to fly solo. So here is your next question. I want you to first think about what do you label each of the sides, then think about the trig ratio that's involved, and then find the side which is this one over here. I will gladly assist students if they get stuck, but I want you to try and do this by yourself and choose options A, B, C, or D. And just pop your hand up if you have a question. So what do we have here? If we label the sides, that would be O, that would be H, and that would be A. Now, I want O and I have H, which means the trig ratio sign must be involved, and I get the sine of 64 is equal to the little a over here over 10.8. I want you to figure out using that equation which is the correct answer for the length of the yellow a there. So what we see now is we have to bring this 10.8 to the other side. So 10.8 times by the sine of 64. And what we then see is the correct answer is going to be 9 points. Well, when it rounds it off, it's going to be 9.7, or it's going to be C. Okay, so finding sides using trigonometry is just a matter of knowing what do you want, what do you know, and then matching the trig ratio, and then just isolating the side that we're looking for. Let's try another one. Ooh, interesting. Okay, can you identify the correct option, the correct calculation that would find the value of m? And m is just the side over here. So there's m. Which of the four options do you think would match the value of m there? I'll give you a little hint. If this is the reference angle, that would be O. This would be H. That would be that. Which one here do you think will match or give me what I want? What trig ratio involves? So we'd say the cos of 25 would be equal to m over 6. Is there anything that looks like that the cos of 25 is equal to m over 6 or a over h? Well, there's nothing that looks exactly like that, but maybe there's something that looks very close to that. It's definitely not this one. I'm thinking that if I bring this 6 to the other side, it could be written as 6 times cos 25 equals m, or I could write it as cos 25 times 6. So this would also be, that's a closed bracket. And so the correct answer would be A. Give me a thumbs up if you follow why the answer there is A. I know it's a bit tricky. See if you could give me a thumbs up if you followed what I did there. Okay, fantastic. Let's go to a slightly different type. Oh, let's do this one actually. Let me not jump ahead too far. Okay, so you are given the following triangle. You need to find me the length of, let's go with the length of AB. So let's first find the length of AB and then find me the length of BC. So over to you guys and girls. Can you find me the length of AB using what you've learned about trigonometry so far? How would you set this up? Not to be boring, but I always think this is a great way to start. Find me the yellow one. In fact, let me call it the length AB. So you know what O is. You want H. So the trig ratio that's involved is sine. And you are going to say that the sine of 37 is equal to O over H. So it's 16 over H. But the problem you have is that that H is stuck at the bottom and you'd really like it to be by itself on this side. So you're going to move that H across and it's going to end up over here. But now the H wants to be all by itself. And so the H is going to be equal to 16 divided by the sine of 37. And that should give me what H is. What are you guys getting for the size of your H? I'm going to type it in my calculator. So 16 divided by the sine of 37, and I get 26.5. If I was rounding off to two decimal places, it's 59. 26.59. Now, I want you to find me the length of the green one. So we found the length of the yellow one is 26.59 centimeters. Can you find me the length of the green, or BC? Can you find BC? So if we want to find the green one, we need A, and we've got O, so I'm going to use the ratio tan. So I'm going to write the tan of 37 is equal to O, so 16, over A, which we don't know. The same as last time, we're going to move this A to the other side. And when I do that, I'm going to have the tan of 37 next to it. So tan 37, and that is then going to be equal to 16. And you can see where I'm going with this, because now the A, or the length of BC, is going to be equal to 16 divided by the tan of 37. And what are you getting when you put that in your calculator? So 16 divided by the tan of 37, and I get 21.23. So 21.23 is what I get for this thing here. 21.23 centimeters. Give me a score out of 10 for how well you think you're able to do this finding the length of sides using grade 10 trigonometry. In the next lesson, I continue, and I want to get a feel for how well you understand finding sides using normal trigonometry. Give me a score out of 10. 10 is perfect. 0 is no understanding. How well do you understand what I'm currently doing here? Okay. Cool. So it's been worthwhile to go through this. Now, the last thing we're going to do for tonight is we're going to do this a little bit in reverse. So instead of being given a missing side, I'm now going to give you a missing angle, right? So if we look at this, this is the missing angle. And what we do is we go through and we label our sides. So the 7 is going to be the O, and the 10 is the H, because it's opposite the hypotenuse. Then what we're going to do is we write the side of the reference angle is equal to O, which was 7, over H. And this is a trig equation. But in order to get the size of this angle, we cannot use the normal sine function. We have to use the inverse sine function. And we apply the inverse sine function to both sides here. And ultimately what we're going to get is just x is equal to inverse sine of whatever the ratio was. And the ratio is 7 over 10. So find me the angle for shift. And the way we key this in your calculator is you go shift sine, and then you go fraction 7 over 10. And then I want you to choose the option that you think is most accurate here. Is it A, B, C, or D for finding this angle over here? So on my calculator, when I go shift sine 7 over 10, I get 44.427. Now, when you round that off to 1 decimal place, it's going to give you 44.4, which is going to be this one here. This one is close, but that one is the closest. So this is when we use trigonometry and we're given two sides and we work backwards and we find the reference angle. Let's do another one of those just to keep practicing. Find me the answer for this one where you're trying to find the angle X. Find the size of the angle X. Okay, so let me identify which is what, who's who in the zoo. I first have to get my directions. So that's O, that's H, and that's A. Then I ask myself, what trig ratio involves O and A? It's tan. So I go, the tan of X is equal to O over A, which is 10 over 8. But in order to get the X by itself, I have to apply inverse tan here, which then unlocks the X. But then I have to apply inverse tan to the 10 over 8. So the way we write inverse tan on our calculator is it's just like a little -1 there, and we go 10 over 8. So what do I get? So shift tan, fraction button, 10 over 8, close brackets, and I get 51.34. So if I was rounding that off, I would get 51.3, which would be option C. Okay. So I think, all right, I'm going to call it at that point for now. If we look at what we've done today, we looked at the different names for the different types of triangles. We looked at some notation and how we describe triangles. We looked at how to solve for unknown angles and sides in triangles. And then this last bit of tonight, we looked at how we use trigonometry to solve for unknown sides and unknown angles in right-angle triangles. In the next lesson, what's going to happen is we're going to start to learn if we have triangles that are not right angled. Say we have a triangle like that, or we have a triangle that looks like this. This is not a right angled triangle. This is an obtuse angled triangle, and this is an acute angled triangle. It turns out that you can think of clever ways. There are clever ways in where we can use trigonometry in these types of triangles. And so that's where I'm going to start in the next lesson. That is where grade 11 trig carries on, is that we learn how to use grade 10 trig in clever, sneaky ways in non-right angled triangles in grade 11. Okay,